So what is a controller system? A little bit of introduction to a control system. Control system is a system which provides the desired response by controlling the output of the system. The control system is represented usually by the single block. If you can see here, you nampak cursor saya ke?
Nampak.
Nampak okay. So you can see in this block, this is the control system. In a control system, we have an input and the output. However, we are trying to control the output by putting a desired output. Maknanya kita nak output tu di dalam satu range yang kita boleh control. Okay, so that is why we call it a control system. So usually a control system can be an open loop like this, or it can also be a closed loop, which the output will become the input of the system and go back. Okay, so example of a traffic light control system or a washing machine. Contoh dia nanti kita akan tengok lagi lah in detail. How is actually the control system works in a traffic light system, and how control system works in a washing machine. Okay, so an example of traffic light system. Mana gambar ni? Okay, a sequence of input signal is applied to the control system. For example, dalam traffic light system, kita ada sensors, so we know how many cars in a junction, for example. Saya sepatutnya ada gambar kan, tapi tak mau keluar. So imagine there is a junction, and then bila dia nak onkan the traffic light, we always wanted the traffic light to be green when it is there are cars. So kalau dia tak ada kereta, tak payahlah dekat situ hijau kan. Kita nak dia supaya jalan yang ada kereta yang pula boleh lalu. So usually we are looking at number of cars that are there at each side of the junction. Okay. So katakanlah input dia lah the number of cars on the sides of the junction. So output dia lah kita nak control the duration, so that the duration will not be too long of waiting. Sometimes we do sit at the traffic light and we wait for nothing because there's no cars moving. However, we are just obeying the red lights, right? So kita tak nak lah benda tu berlaku lama sangat. Because when that happens, people tend to disobey the traffic light. Orang mula nak langgar lampu merah disebabkan lama sangat tunggu lampu merah yang tak ada kenderaan. However, kadang-kadang bila dia jalan tu, masa tu lah accident can happen. So we don't want that to happen. So we want to control the number of time, the duration for the time that the traffic lights is green and red according to the number of cars that exist on the each side of the junction. Okay, so based on when the one light is on, the other two lights will be off. Okay, so based on the traffic study at a particular junction, for example, the on and off times of the light can be determined. So we are trying to control the output by having the input to the system. Okay, siapa yang on mic ni? Tolong check jap. Ada bunyi bising sikit. Okay, so accordingly, the input signal control the output. So we are trying to control the output of the system. So dekat situ yang kita ada control system. Okay, control system ni tak semestinya fuzzy. Tapi kita nak kata that is a control system. Apa maksud control system? Yang ada, there is a system that we trying to control the output. So that the output is in the range that we want. Okay, the desired output. Okay, some other examples of a control system is alignment of the front wheel of a vehicles. We want it to be controlled so that it follows the how much does the driver steer the wheel. Kan you duduk dalam kereta when you drive, you steer your steering kan, you pusingkan steering tu. When you steer your steering, you expect that the wheel, the front wheel of your vehicle will move accordingly. So tak adalah you pusing sikit, dia pusing you punya kereta kona banyak. Ataupun you pusing banyak, penat dah, you tarik steering, but then you punya roda cuma berpusing sikit. So dia nak berdalam satu dalam satu situation tu kita nak it is in a controlled situation, which is we want it in a desired angle. Kita banyak ni kita pusing, banyak tu juga kita expect the front wheel to move. Okay. And other examples are the rudders of a boat. Okay, sama juga cerita dia macam steering wheel juga. Kalau kita bawa boat, dia berfungsi sama macam kita kata a car tadi. However, in a boat, we still using the rudders. So the rudders yang kat bawah dia tu akan bergerak mengikut how much we turn the steering wheel. Okay. Another thing, another example of a control system is the concentration in liquids so that it will follow a given set point. Apa contoh liquid yang you always want it at the same concentration? Anyone can answer me? Concentration, kepekatan liquid. Tak ada jawapan. Kopi. Betul? Kalau you pergi beli kopi, contoh you pergi Starbucks, ataupun you pergi beli kopi yang dekat mesin, dekat Costa kononnya. Sometimes Costa dia ada dia punya counter kan, manusia yang bancuh. Sometimes you have some machine for the coffee. So you always want the coffee or your drink in the same consistency, the same concentration. Betul tak? You tak suka hari ni pergi beli tiba-tiba dapat kopi cair. Kurang susu, kurang kopi, betul tak? However, benda tu dia bergantung kepada banyak benda. Sometimes the concentration always depends on the temperature of the drink. Kalau you minum minuman tu dah sejuk, dia punya kepekatan dah berubah. You minum kopi dah sejuk tak sedap kan? You nak kopi tu panas-panas. So the right temperature, panas sangat pun you tak boleh nak minum, it burns you. So it has lots of things to consider. And then bila you nak minum satu drink tu, tak semestinya kopi lah. Kalau you beli juice pun in the box, contohnya you pergi dekat pasar raya and then you go to the chiller section tu kan, dia ada juices in the box, in the bottle and so on. Katakan you ambil satu juice, you suka dengan this kind of juice, contoh one brand, you really like it. Tiba-tiba satu hari kalau dia tak ada control system on the concentration, juice yang dijual tu cair. So mungkin you rasa macam, ish tak berbaloi you beli kan. So you want it at one given set point, dia kena rasa dia consistent. Okay, concentration tu pun kena consistent. Dia tak boleh kurang manis, kurang rasa dia berbeza, dia akan menjadi masalah kepada production tu sendiri. So usually the concentration in liquids is really a big matter for manufacturing companies, especially those who produce foods and drinks. Okay, so benda-benda macam tu lah. Selain daripada tu, it also affect the concentration ni juga penting dalam machineries. Sometimes untuk contoh bila you produce minyak, tak kira lah minyak apa pun, minyak pelincir pun especially, it must be in the same concentration. Dia tak boleh berubah-ubah. Kalau berubah-ubah, it is not in the given controlled set point, it will make that it will actually cause some problems in the machine itself, and that will give you another problem later on. So those things are the thing that you have to be in control. Sebab tu you can ada control system in each of this machine. Okay. And then another example is a temperature of furnace. So you need things in the same temperature for anything yang melibatkan temperature, you need the temperature in one set point. Ini contoh dia. The most close to us is an air conditioning system. Kalau kita letak temperature dekat, kan bila kita pasang aircon, kita set temperature 25. So 25 tu adalah you punya set point. So you want the temperature in that room is always at that set point. So you need it to regulate in that point sahaja. Kadang-kadang bila hari panas, dia akan jadi lebih panas. So you nak di dalam set point yang sama. Jadi a control system in there will make sure it changes all the mechanism that it has to make sure it find the right temperature. Okay, so there are some examples of control systems. Okay, so this is an open loop control system. Well, we said an open loop control system means that the output is not given back into the system. Okay, the output akan terus pergi kepada you punya machine atau anything. It won't be in the input. It won't become the input. However, usually you will want to have a closed loop control system where you will use the output as a feedback to your system. So you know how much you have to change, how much to regulate, so that you can always be at the given desired output. Okay, you nampak kat sini berbeza dia. Open loop, plant ni you punya machinery lah, tak kisah apa saja pun ya, you bagi dia punya you punya output of the controller tadi, the signal, and then you just go through the plant. Plant ni can be, bukan plant ni pokok tau, plant ni can be anything, okay, for your system. And then you will have the output, tapi output tidak diberikan kepada controller balik. Jadi controller tidak tahu, the controller cannot control because the actuating signal is given to the plant, so the output is not coming from the controller itself. So dia tak boleh nak control. So this is an open loop control system. So the one that you have here, you already give your output to the plant, and the plant have gone through some processes, and then there is the actual output. You want to know, is that actual output is meeting your set point or not? So you akan kira error dia daripada you punya desired output. So dia akan kira error, and then dia akan adjust. The controller will adjust the any signal that they have, so that it can be always inside the range that you want. Okay. So what are the factors that affecting a control system performance? How do we say that this control system is a good control system or not? Okay, so one of it is the choice of the controller's algorithm itself. So the algorithms can be anything. Yang paling popular macam-macam lah dalam mechanical, dalam electrical, ada macam-macam controller punya algorithm. Okay, however, yang kita nak fokus dalam this class is the fuzzy control system. Alright, and then how are we going to make sure that the system, the control system perform better is by tuning the controllers. Sebab tu saya tadi, kalau saya, I would prefer the closed loop system, because the closed loop system gives back the output into the system, so that we can know how much we have to adjust. Kalau kita tak tahu tu, kita just set aja kita punya desired output tu, tapi kita tak boleh nak control a lot of things, right? And then selection of control variables. Kalau kita salah pilih variable, it actually doesn't reflect the decision making in the system, what to control. So it does have it will affect the control system performance. Okay. And the other one is the selection of the performance index itself. How are you going to say that it perform? Are you looking at the accuracy? Are you looking at the deviation of the temperature or anything? So you can identify apa performance index yang you nak tengok kat situ. Okay. Another thing is the type of sensors that you are using. Adakah sensor you gunakan tu giving you the right measurement and for the system to control. Okay, and the actuators. Actuators are the things that you giving the action to perform. So kalau actuators tu sendiri is not a good performer, so it won't perform better in your control system. Sometimes in systems you also have some disturbance from the environment. So bila dalam environment, this disturbance is the environment that you cannot control. The variable that you cannot control. Okay, contoh macam air conditioning system tadi, kalau kita pakai aircon tu dalam musim panas, you tak boleh control cuaca kat luar. Okay, so you tak boleh nak kata yang you boleh control banyak mana gas yang you nak gunakan dalam that machine. You cannot control. You can put the set point of the temperature, however you cannot control everything, all the environment variable there. Okay, and then sometimes a controller system also being affected by noise. Okay, so noise are some unrelated data, unrelated variable, unrelated information that comes into the system and actually disturbs the system. Okay, and then the other thing is how you configure the controller, your design, and the non-linearity of the variables that are involved in your control system. Okay, so these are some performance indexes that you look at. So this performance indices is actually the thing that you use to measure how good a control system is, right? Sometimes you look at the integral squared error, integral absolute error, time absolute error, time squared error and so on. Usually you are looking at error. Yang error ni biasanya kalau you guna closed loop system lah. Okay, if you are looking at a closed loop control system, it has the error sebab you ada input tu kan. So you boleh kira apa beza yang sebenar, the actual output dengan desired output. So that is the error. However, sometimes that is not what you are trying to control. You are not controlling the error itself. You are controlling other things. Contoh, you are trying to control the minimum fuel, you are trying to control the time, and etc. Some other indexes. So you have to identify in your system what is the control measure that you are going to use. So this performance index is actually giving the right view of how does the control system perform. Okay, this is an example of analysis in time domain. Okay, kita tengok dekat graf ni Saya masa mula-mula belajar pasal control system ni saya pening sebab saya bukan daripada bidang electrical engineering. Orang electrical engineering benda ni mungkin dia mudah faham. Okay, so this is a graph where you are trying to achieve some katakan this is the output that you're looking at. You are trying to set the signal supaya signal tu controlled in this range. You nampak tak range yang line yang you setkan dia yang desired adalah line putus-putus tengah-tengah ni. Can you see it? Yes. Okay, contoh So this is your desired output. So you nak your system output dia kalau dia pergi pun dia akan sampai kat sini dia akan berhenti. Sebab dia contoh kalau nak mudah nak faham, you bayangkan you buat lift, sistem lift. You naik lift, biasa kan naik lift kan? Okay, you kata nak pergi tingkat 1. So you daripada level ground floor, you masuk lift, you tekan level 1. You bila lift tu naik, dia tengah bergerak naik ke atas. You nak dia berhenti dekat level 1. Okay? So bila dia sampai dekat level 1, biasanya dia akan ada some kind of, we call it as overshoot. Sebab inertia kan, dia bergerak ke atas. Bila you brake pun dia akan macam ada terlambung sikit. Tu kadang-kadang kita tak nak lambungan tu banyak. Kalau tidak nanti orang yang naik lift tak selesa. Dia akan menyebabkan masalah lain. Orang sakit perut dia buatnya kalau lift tu duduk goyang-goyang kan. So you want the lift naik and then sampai kat level 1 berhenti. Tapi you tak naklah dia naik slow sangat kan. Nanti bila tahu nak sampai kalau you pergi level 13 lamanya nak sampai kalau dia naik dek. Kononnya nak kurangkan overshoot so you naik slow. So tak boleh lah. So you kata okay dia naik, kena naik laju sebab you nak tahu you sampai cepat. Tapi sampai situ you nak dia berhenti betul-betul on time. Dekat level tu dia kena berhenti. So you imagine kalau you sampai dekat number 1 ni, you nak dia stop here. However usually disebabkan oleh inertia on zone, dia ada lanjakan tu. Lajakan tu kita panggil overshoot. Okay. So biasanya dia akan naik lajakan overshoot. Lepas tu dia akan turun balik. So kita kontrol kan. Kita kata kita nak output tu di sini. So dia akan turun balik. Tapi bila turun pula dia ada pula lajakan ke bawah. Tapi lama-lama dia akan stable. So dia akan start settling time tu bila dia duduk dekat dalam satu range yang kita terima. Kita katakanlah dia punya tambah tolak. Kita bagi some range. Dekat dalam range tu kita terima. Okay, so yang dia punya steady state lah, alright. So kita cakap kepada steady state dia. Okay, this is the rise time. Masa dia naik, rise. And then this is the peak. Okay, bila dia sampai dekat dia punya highest peak. Okay, bila dia masuk, dia start settling inside the range. Walaupun mungkin dekat sini dia mungkin tak terus steady Mungkin dia ada lagi some movement here in the signal. So kalau masih ada movement kita kata tapi di dalam range yang kita terima, so this is kita panggil the settling time. Start je dia masuk, this is the settling time. Usually kita nak minimumkan settling time ni sepanjang daripada 0 to settling time. Tapi kita nak rise time dia cepat. Biasanya kita tak nak dia lambat-lambat rise. Okay, we want the rise time to be minimum, and we trying to minimum the settling time supaya dia tak lambat sangat sampai dekat tempat yang kita nak. Can you understand this graph?
Boleh benda.
Boleh so this is actually how we identify something in time domain. Kita nak tengok is the signal that we are producing from our controller is achieving what we want in time domain. Biasanya kalau dia punya measure is time lah. Okay. So This is how you observe the system time response, okay, to measure the swiftness. How fast do you reach your rise time and your peak time, and then how fast do you settle in the desired environment. Okay, so to measure the closeness of the system response to the desired system, you can check overshoot. Overshoot tak nak banyak sangat. Okay, overshoot ni dia tengok, dia measure daripada, kalau you tengok overshoot adalah daripada the peak to the desired range. Maknanya berapa banyak dia overshoot. Kalau overshoot tu besar, kita try to minimize it. Okay. And then kita nak tengok tadi, saya katakan berapa lama dia nak start to settle. This is a settling time. The rise time. And then berapa error dia, steady state error dia. Okay, this is the steady range. Okay, so berapa error yang kita nampak. Error adalah perbezaan lah. Macam overshoot ni pun error jugalah. Maknanya how much does it deviate from the desired state. Okay, and so on. So you can, from one graph like this, you can see a lot of analysis. So in control system, these are some kind of analysis that you do lah. You have to identify these things. So this will be the measure that you use to identify is your system, is your controller, is a good controller or not. Katakanlah this is one from one controller. Mungkin you guna PID controller. Lepas tu you buat satu lagi, you guna fuzzy controller. So you nak kata which one is better? Is my fuzzy controller is working better from the normal controller? So you pun tengoklah, ini antara analysis that you can do. Okay? So basically control system used in a lot of machines, a lot of things around us. Okay, so dalam kereta, cars, aeroplanes, trains, ships, these are all vehicles. Kalau vehicles, control system dia banyak benda lah. Especially nowadays, we are going towards having lots of intelligent vehicles, right? So bila katakan macam contoh sistem Tesla tu kan, kereta dia can drive itself. Bila kita nak dia drive itself, we want the system to be in control. Kita tak naklah dia drive tu macam budak baru belajar memandu kan, ke kiri, ke kanan, goyang-goyang, semua tu tak nak. So kita nak dia drive smoothly, in the lane, no collision and so on. So there are lots of things. So banyak benda macam ni kita kena ada control system lah. So there are lots of control systems used in all of these kind of vehicles. Okay. You all biasa travel dengan aeroplanes? Train? Biasa You know aeroplanes have their punya autopilot kan? Dia bukannya pilot manusia tu yang terduduk drive all the time kan? Sebab biasanya aeroplanes dia punya travel is too long. Dia punya duration dia lama. Ambil masa berjam-jam sampai 24 hours pun ada. So as a human being, we have the problem of being tired. Kan? So we need the system of the aeroplane itself that can help the human being. Dia tak replace it doesn't replace the human being, but it's actually helping by giving time for us to rest and for the pilots to actually regain their energy and to have their mental state and physical state at the best performance. Sebab tu sebenarnya dia buatnya ada sistem yang boleh autopilot ni. Because in some condition we don't really need a human. Contoh bila dalam keadaan yang smooth sailing, tak ada apa-apa, so they just go at the same parameters, tak ada apa-apa yang mengganggu dia, the autopilot can go. Tapi kalau in some conditions with the turbulence and so on, kita nakkan the human to control it. Itulah sebabnya kita perlu to have this kind of control system, kind of autopilot system lah. Even with the human driver, we still need some help from the control system because we cannot actually control every single thing in our environment kan. Contohnya dalam kereta lah. Okay. Dalam kereta yang macam kita sebut tadi, the steering wheel, kita tak boleh nak control wheel tu pusing banyak mana. Kita pegang steering wheel je. Kita tak boleh pegang tayar kat depan tu kan. Waktu driving, takkan kita pergi keluar tengok tayar kan. The best thing we can control is the steering wheel. So we want the steering wheel and the actual wheels, the front wheels tu moving with the same they are talking work fine dengan dia punya the right angle and so on. Okay, faham maksud saya tu? Takut maksud tak sampai. What about trains? Kita ada sistem trains yang canggih sekarang kan?
Ada.
Okay, siapa biasa naik ETS?
Saya.
Biasa naik ETS So what do you think there is in ETS that you think that this is a good control system? Cuba bagi contoh.
Contoh daripada Ipoh nak ke Tapah. Lepas tu dia macam dia memang dah tepat masa dia. Kalau pukul 10.30 tu jadual 10.30 dah sampai.
Kan? Dia control by that time tu, the arrival time, even arrival time dekat you waktu you menunggu dan juga arrival time to the destination kan? Macam mana dia control tu? Dia mesti control banyak benda. Dia bukan control time. Dia tak boleh control time. Siapa boleh control time? Nobody can control time. So what they can control is the speed of the train kan? Lagi? Masa dia berhenti dalam ETS macam mana you rasa?
Bila 1 kilo sebelum tu dia dah perlahankan sikit.
Dia dah slow down kan? Sebab dia tahu kalau dia teruskan dengan the same speed, the momentum will be very big kan. Terlambung you kalau nak berhenti tiba-tiba. So you had about 1 kilometer dia dah start slow down kan. Okay, and then bila sampai dekat tempat yang dia patut berhenti, macam mana? Dia ada pintu ke tempat dia berhenti tu?
Ada.
Maksud saya pintu you keluar tu sama tak dengan pintu dekat stesen?
Sama, dia dah synchronize kan.
Kan, dia berhenti betul-betul dekat pintu, dia tak ada terlajak, supaya kalau terlajak kan you nak keluar macam mana, pintu stesen lain, pintu dia lain kan, pintu train tu. So it needs to be control. Yang itu pun control juga, yang itu controller lain pula. So a lot of control system dekat situ. Okay, dia nak kena control the movement in case ada apa-apa perbezaan in the environment, the system need to control. Okay, alright, and then okay, we look at another example of the control systems. Okay, kita ada washing machines, refrigerators. Okay, dalam washing machine, siapa boleh bagi tahu contoh? Apa control system dalam washing machine?
Dia punya heat.
Air.
Temperature. Air.
Dia punya automatic berat tu.
Yes, berat kain tu kan, yang you nak basuh. Tapi dia tak control berat kain tu. Cuma that is the input to the system lah kan. Dia nak control berapa lama basuh, berapa banyak air nak masukkan. Okay, in the washing machines. What about refrigerators? Apa yang dia nak control dekat dalam refrigerators? Temperature, correct. Especially dalam negara yang panas macam kita kan. Waktu malam sejuk, waktu siang panas. Okay, so memang kita kata apa nak pening, madam, temperature dekat refrigerator kat dalam rumah. Betul, it's inside. However, the environment does affect the temperature inside the refrigerators kan. How much does it have to increase or decrease pada hari yang panas dan hari yang sejuk, it difference. Okay, and then kita tengok other than that we have the disk drive, stepper motors. Itu semua machines. Kalau kita tengok yang atas daripada disk drive and above, is all the we are talking about electrical and electronic and machineries. Okay? But however, there are some other things that we are trying to control as well. Contoh kat bawah tu chemical processes in food. Okay? Kalau you all ada ladang ternak lembu contohnya, do you think any control systems are needed there?
Ada.
Ada kan? Sebab usually when you produce milk, especially yang fresh milk, you have to pasteurize. You need them to be in the same consistency. You need them to be good until the expiry dates. Kan, there are lots of things. So you have to control the chemicals substance. Okay, berapa banyak perasa yang you masukkan so that your products will not be too sweet, can be acceptable, a lot of things. Okay, kalau kita kata alah madam itu resepi je, control je lah through the recipe. Yes, Tapi kalau you biasa masak, kalau you ikut resepi pun, saya suruh orang A masak dengan orang B masak, still rasa dia akan berbeza kan? Even following the same recipe. Betul tak?
Betul.
Kenapa dia berbeza? Apa yang menyebabkan
Sebab
berbeza? Resepi sama.
Manusia tak konsisten.
Betul? Dari segi apa tak konsisten nak masak?
Kalau dia ikut resepi sekalipun, dia punya amount tu takkan sama dengan orang yang satu lagi.
Betul? Tepat. Kalau dia masak, katakanlah dia dalam resepi tu dah tepat dah. Dia kata masuk satu sudu lah. Tetapi satu sudu masuk pada saat yang berbeza akan memberi kesan yang berbeza juga kan?
Betul.
Contohnya seorang ni masak satu sudu garam, kawan ni pun masak satu sudu garam. Seorang masukkan garam masa awal masak, seorang lagi masukkan garam lepas matikan api. Rasa dia akan berbeza sebab garam tu tak react dengan the heat of the cooking. Kan? So dia punya reaction akan change the chemical process inside the food itself. So the taste will be different. Other than that, sometimes the quality of the ingredients itself berbeza-beza. Even though kita kata kita gunakan sayur yang sama, tetapi satu sayur ni dipetik 2 bulan lepas. Yang satu ni saya baru petik kat belakang rumah, katakan. So the freshness of the ingredients are different. So the taste will be different. How to control it? So kalau you buat satu syarikat produce makanan, you have to think a lot of things involving the chemical processes. Okay, dia bukan lagi machinery punya controller, but more on chemical things. Dan to control the chemical stuff, you need a lot of sensor lah yang boleh read all the ingredients punya substance dalam tu. Okay, and then we have yang bawah tu contoh lain ialah robotic manipulators. Okay, so yang itu pun more on machineries lah. Alright, so in control systems, there are a lot of techniques that can be used. Control system ni dah lama orang start study, okay, the research of it. So there are some different techniques being used. The classical techniques used in control is the left-hand side in the slide. You can see the root locus, Bode plot, Nichols chart, and Nyquist plots. This is more of mathematical studies on that. Okay, and then they start to come out with modern techniques. So bila dia dah modern ni, dia more on looking at the feedback. Tadi kita dah tengok dia ada feedback control system kan? Okay, state feedback, state estimations, and they have some observers. Observers need to look at the other inputs, other environments inputs to the system. And then bukan sahaja dia boleh control, sometimes they can do some optimization on top of it to find the best output of the system. Ada juga dipanggil sebagai robust control, H infinity, internal model control, and adaptive control. So we are not going to look at the other parts. We are focusing on the AI control design techniques because that is what we are looking at. Okay, so in AI pun ada macam-macam. They use neurocontrol. Neurocontrol ni guna neural network, okay, where it starts to learn, do some training, learn from the past data, so it can control the environment according to the past data. And then we also have fuzzy control. One good thing about fuzzy control is sebab fuzzy ni kita tahu dia ada soft edges kan, dia tak terlalu abrupt. So katakan bila kita nak buat controller system tu, dia tak terlalu abrupt dia punya changes. Because of the soft edges. Kita tahu kita selalu panggil fuzzy ni sebagai soft computing kan. Kenapa kita panggil dia soft computing? Ingat lagi, kita punya fuzzy value tu selalunya dia ada range. Dia tidak kata yes or no. Kalau tu very abrupt. Kalau sistem controller kata oh yes, kena ubah signal. Tiba-tiba no, you kena ubah signal. So it is very abrupt. But in fuzzy controller, it has some kind of a range before it can changes from one value to another value. Sebab tu you tengok degree of membership tu ada 0 to 1 kan. So dia ada some soft edges, ada grayscale dekat situ sebelum it reach one state. So that's why fuzzy controller is becoming more popular each days. Okay, and then sebab kita sebagai human being pun kita tak suka something yang berubah terlalu cepat. However, in some in some environment, we do need that kind of thing. So it depends lah on the domain itself. Okay. And then dalam AI, control design techniques, there is one which we try to implement genetic algorithms. You all dah belajar genetic algorithms ke belum ni Yang ini you akan cover in part 5 kot optimizations. So genetic algorithms ni another technique that can optimize, find the best solution from all solutions. Okay, so tu kita guna genetic algorithms. And then in AI, the control design also we use some knowledge-based system. Yang ini you dah belajar. Apa kelebihan knowledge-based system? You dah belajar, saya tanya lah. Apa kelebihan having a knowledge-based system?
Pass knowledge.
Yes, we can have some knowledge. Yes, apa dia? I heard someone saying something. Tak ada. Okay, so knowledge-based system ni lebih dia that we can incorporate some knowledge from human expert into the system. Okay, so but because usually that the controlling may be being done by human, so we want the control system to act like human as well. So we are trying to incorporate some rules, for example, rules, cases. You dah tengok dalam knowledge-based system lots of model kan? Kita ada rule-based, ada case-based. So you can use all of this to be incorporated in the control system. Okay, so these are some example of controllers that can be applied in control system. Conventionally, there is an algorithm called a bang-bang on-off proportional and PID controller. Tapi kita takkan cover yang ni lah. Yang ini more to electrical and electronic punya controller system. And then they sometimes have adaptive controllers. Adaptive controllers are the controller that not only control and they can self-adapt. Okay, so they self-adapt to the condition and the environment. Dia berubah sendiri. Dia auto-tuning, self-tuning, PID controller. And then they also have predictive controllers. Predictive controllers are the controller that can predict the output. Dia bukan saja control the output at the current situation. It can predict in the future apa yang akan berlaku. If the environment changes like this, what will happen? So these are the predictive controllers. Okay, so the other one is the intelligent controllers. Yang ni yang kita sebutkan tadi lah. Kita buat knowledge base, fuzzy logic controllers or neuro controllers. Sometimes we combine fuzzy with neuro, so kita ada adaptive fuzzy. Okay, so why are we going to use fuzzy control? Right, during the past decade, fuzzy logic control has emerged as one of the most active and fruitful research. Sebab fuzzy punya perangai fuzzy tu sendiri, the characteristics of having fuzzy logic itself is actually good in the control system. Okay, so the idea was first proposed by Mamdani. You already heard about Mamdani before, right? So dia yang mula proposekan why not we use fuzzy inside a control system. Okay, and many industrial and consumer products using fuzzy logic technology have been built and being used all worldwide. So in contrast to conventional control techniques, fuzzy logic control is best utilized in complex, ill-defined processes that can be controlled by a skilled human operator without much knowledge of the underlying dynamics. Okay, maknanya kalau sistem proses yang you nak control tu can be controlled by a skilled human operator. Okay, skilled human operator you kena faham skilled maknanya bukan sebarang manusia, maknanya manusia yang ada skill dalam controlling that process. Okay, kalau you nak buat satu control teknik dekat bidang yang macam ni, okay, it is very good because biasanya skilled human operator ni, because of the skills kita buat bukan sebab kita tahu sangat, not much knowledge of the underlying dynamics, tapi kita buat sebab kita dah biasa. Faham maksud saya? Kalau orang dah biasa masak, dia masak tu sedap aja you katakan. Tapi kalau you tanya betul-betul macam mana cara masak, susah dia nak cerita setiap satu tu. Susah dia nak cerita bila timing keberapa, timing minit keberapa nak bubuh garam. You tanya pun dia tak boleh jawab. Dia tahulah, dia tengok bubbling ke apa ke, dia based on dia punya experience. But dia tak boleh nak ceritakan every knowledge yang ada tu. You faham maksud saya? Maknanya skill ni, maknanya dia benda tu dah, we are skillful because of the training. Bukan sebab we learn that kalau kita masukkan waktu ni dia akan jadi macam ni, kita buat macam ni dia jadi macam ni, bukan. So fuzzy ni sesuai dalam keadaan yang begitu. Sebab it can make the system works better. So the controller will work better in that sense. Okay, faham tak maksud saya kat situ?
Faham.
Faham? Okay. Sebenarnya banyak perkara yang macam itulah. Macam contoh dekat dalam kilang, you can imagine in manufacturing companies on the line itself, the production line. Katakanlah dia produce something, sebelum ni dia dapatkan mesin, manusia yang buat. So the human is very skillful of doing it. However, they don't really understand how to do it. Kalau you tanya dia kenapa, mungkin dia tak boleh jawab. Tapi macam mana? Boleh, dia buat aja. Sebab dia dah skillful. The skill is there. Dia tahu bila dia nak react, dia tahu apa nak buat. Okay? Biasanya begitu. Jadi dalam keadaan yang macam tu, when we trying to put a machine there to do the same process, it is good to use fuzzy controller. So fuzzy controller ni dia ada soft edge tadi kan, so dia boleh actually react a bit like human rather than the normal, the other conventional control techniques. Okay, clear?
Clear.
Alright. So this is the picture of Professor Ibrahim Mamdani. He is the founder of Fuzzy Logic Control. Okay, gambar yang ada dua orang ni. This is my professor dulu masa-masa saya study. Allah yarham Prof Marzuki. Okay, so this is Professor Mamdani. Okay, saja je lah letak gambar. One day, if you do something good, you want people to know you, right? Okay, so this is fuzzy logic control. Any question setakat ni? Is it clear?
Clear saja.
Ya.
Okay, so the basic idea behind fuzzy logic control is to incorporate the expert experience of human operator in the design of a controller, okay, in controlling a process whose input and output relationship is described by some fuzzy rules. You know some rules, you dah belajar kan fuzzy rules? So you can actually define what is the input and output relationship. So you can actually use those fuzzy rules into your controller system. Okay, so this utilization of linguistic variables, the fuzzy control rules, okay, and approximate reasoning provides a mean to incorporate the human expert experience in the controller. Kalau kita guna conventional punya controller, dia tak ada these rules that you can incorporate. So we have fuzzy logic controller to incorporate those rules. Okay, so macam saya cakap tadi lah, right? So benefit of fuzzy control system is it is suitable for complex, ill-defined system. Okay, and then it is able to design along linguistic line. So we can use our own language. Bila kita tanya dengan our operators, they can use their own language and then we can use those language. Dia tak ada tepat-tepat kena the timing kena berapa second, millisecond, so on. So we can use some the linguistic value because kita tahu fuzzy kelebihan dia boleh menggunakan linguistic variables. Okay, so this can be incorporated into our rules. So it is found that fuzzy control better perform than conventional PID controllers, and it is much simpler to design. Okay, so where do we start when we're trying to design a fuzzy logic control system? We have to know what are the basics needed and what are the components. So kita tengok satu-satu lah. Okay, so this is a fuzzy logic control system architecture, right? We start with a set point of reference. Usually a fuzzy logic control system is a closed loop system. Okay, so kita nak tahu apa yang kita boleh ubah, berapa banyak kita boleh ubah according to the output. So output tu sendiri akan ada perbezaan dengan apa yang kita nak kan. Output ni ada dua, satu actual output, satu lagi desired output. Desired output is the output that we want. That is the set point. Kita setkan kita nak this value. And then output yang sebenar mungkin keluar tak sama. So kita boleh tengok the error. What is the difference between the actual output and the desired output? Okay, so this is the input. This is where you calculate the error and you put in the error inside your controller. So dalam fuzzy controller ni ada rules. Dia akan lalui the same process yang you buat sebelum ni. Fuzzification, rule evaluation and then defuzzification. That is in the fuzzy controller. Okay, you dah tahu jelas dah this processes, so saya tak perlu nak ulang. So bila you masukkan error, so you can imagine error must be one part of the rules. Supaya bila you fire, you akan incorporate the error yang masuk. Okay, adakah a big error ataupun small error? Okay, kalau big error kita nak action dia akan lebih besar lah. Kalau error tu kecil, contohnya you setkan temperature 25 degrees. Tapi the real output menyebabkan temperature dia 30 degrees. Okay, so 30 tolak 25 tu 5 degree, besar kan? So you nak action dia besar supaya dia cepat naik. Cepat berubah kepada yang dia nak. Atau bukan cepat naik lah, cepat turun. In this case, you nak dia turun lah. Sebab 30 is very high kan? You nak turunkan dia ke 25. Right. However, kalau you setkan 25, output sebenar 26. Beza dia satu je kan? So kita kata the difference is small. So the action will be a little bit small. Sebab tu you kena ada some kind of variable for the error itself inside your rules. Okay, so dalam rules ni kena ada sebut error lah. Okay, and then lepas you dah fire, you kena defuzzify supaya you can have the control signal, and then dia akan keluarkan control signal, dia akan hantar kepada proses yang sebenar lah. Proses sebenar di dalam mesin. Kalau aircon, proses sebenar dia adalah dia punya kipas, dia punya apa, satu blower dia, satu lagi dia punya gas, how much dia nak pump in, semua-semua tu lah. Okay, and then bila dia run, ada sensor yang akan control temperature, masuk balik. Okay, ni sensor ni akan bagi masukkan input tu ke dalam you punya system. Is it clear here? Saya bagi contoh tadi dengan aircon sebab saya rasa aircon tu yang paling mudah nak nampak. Okay, you can think about any other control system if you can imagine. Okay, so those are the things. So you punya group project tu tak semestinya, ada yang tanya saya, Madam kena ada user interface ke tidak? Kalau you buat you punya group project untuk fuzzy rule controller macam ni, output dia bukan kepada manusia, output dia kepada proses of a machine. So saya tak expect you ada user interface lah. Okay, tapi kalau you buat sistem tu, output dia pada user. Contohnya you buat sistem untuk diagnosis some penyakit, namanya user tu sendiri yang akan masukkan input dan user nak tahu apa output dia. Kalau in that is the case, you perlu user interface lah supaya your user can see what is actually the output. Kalau tidak, it doesn't work lah. A system without a user interface, how does your user are going to see it? Kan, betul tak? So kalau you kata, okay tak apa Madam, saya guna MATLAB. Tak ada masalah dengan guna MATLAB. MATLAB will develop your engine. However, how does your user is going to give the input to the MATLAB? Adakah dia sendiri nak kena run MATLAB tu dan key in dia punya input, tapi dekat mana dia nak key in? So dia kena nampak lah kat mana nak key in. Okay, so the user interface is actually one part where it gives your user a feeling that they are talking to the system. Okay, kalau tak ada user interface, tak dapat lah. Okay, ni cerita lain kalau you guna sistem you for a fuzzy logic controller system yang mana output dia bukan kepada human being, output dia kepada machine. So that's okay. That is okay, tak ada user interface. Right, because you are just passing some values through the machines. Okay, so the components of a fuzzy logic controller generally comprises of 4 components. The fuzzifier, which fuzzification comes. Knowledge base, where it keeps all the rules. Inference engine is where you do the rule evaluation. And finally, you have the defuzzifier, yang mana yang akan menukarkan balik the fuzzy value kepada output yang the system can understand. Okay, if the output from the defuzzifier is not a control action for a process, then the system is a fuzzy logic decision support system. Okay, ini maksudnya kalau you punya defuzzifier tu come out with some control action for the process, so kita kata ialah a controller. Tapi kalau dia bukan a control action, dia bagi you decision, so maknanya that is a fuzzy logic decision support system, kita panggil DSS. Okay, But basically it's the same thing. They are the same component. So fuzzy controller itself is normally a 2 input and single output component. Okay, it's usually a MISO system, multi input single output. Okay, you can have 2 input, but sometimes you also can have more than 2 inputs. Sebab tu kita kata MISO lah, right? Bukan MISO soup, MISO system. Alright, multi input single output. Dia tak boleh single input lah. Kalau single input, error tu sendiri adalah satu input kan. Jadi you perlu input lain lah, environment ke apa ke input yang you perlu kan untuk come out with the output. Takkan input you adalah output tu juga sahaja. Dia mesti ada something else yang can change. Kalau tidak, macam mana dia nak berubah? Kalau output saja, single output masuk, keluar balik output tu juga. So it doesn't make sense. Okay. So the components of the fuzzy logic controller looks like this. Sama macam fuzzy expert system kan. Okay, dia tak ada banyak beza lah. Right. So it needs the knowledge base, the inference engine, fuzzifier and defuzzifier. So the design process, first you identify the controller input and outputs. Apa dia punya fuzzy variables, variable for the inputs and what are the fuzzy variables for the output. Then you break up the inputs and outputs into several fuzzy sets. Tadi variable tadi kena ada fuzzy sets dia. So fuzzy sets tu you have to label according to the problem. Kadang-kadang biasanya orang guna low, medium, high. Ataupun positive, zero, negative. Ikutlah apa jenis input dia, variables tu. Okay. So positive can be small positive, big positive. Itu biasanya untuk error Untuk error can be positive or negative. Sebab bila contoh tadi kita sebut pasal temperature, kita set 25 tapi output sebenar 30. So 30 actual output minus desired output dia jadi 30 minus 25 it will become positive. Tapi katalah you set 25 tapi bilik tu jadi sejuk sangat 20 degrees. So 20 minus 25 it become negative. So dia akan jadi negatif. Dia bunyi dia tak macam linguistic. Kan kita kata itu linguistic variable tu dia macam something yang you use adjective to describe kan. Contoh long, short, high, low, that are some adjective. Tapi bila kita sebut tentang positif, negatif, it's actually the same thing. We can use it in fuzzy expert system. Okay, sebab bila kita positif tu can be big, large or is it a small positive. Okay, so dia punya perbezaan tu ada some kind of fuzzy dekat situ. Right, and then you develop the rules to solve the problem. Apa rules yang involved? Kalau setakat 2 input, 2 input, katakanlah setiap input tu ada 3 fuzzy set. Ada berapa rules yang akan keluar? Anyone?
7.
2 input je?
2 input.
9 je kan? 3 kali 3. Dia 2 dimensional kan? Okay. Saya tak boleh nak lukis kat sini. Mana tak pen dia tak mau keluar. Okay. Kalau 2 input, setiap input tu ada 3 variable. Okay. So 1 dimension, input A, input B. Okay. Error katakan ada 3 variable. Positive, 0, negative. And then input satu lagi another variable. Okay. And then variable A and variable B ada 3 dengan 3. 3 kali 3 ada 9. Tapi kalau you ada 3 input dan setiap input tu ada 3 set. Okay. 3 variable, 3 input variable dan setiap ada 3 set. So you akan ada 3 kali 3 kali 3. Baru ada 27. You ingat lagi konsep you guna FAM cube tu. Okay, fuzzy association memory. Ingat tak last chapter rasanya kita cerita pasal tu. Okay. So you akan gunakan that thing to identify berapa banyak rules yang you akan keluarkan. In a fuzzy controller. Betul saya tahu ada setengah orang dia kata, oh madam kita ada 3 input tapi ada juga rules yang ada single input. Okay, kalau macam tu dia akan lebih banyak lah. Tapi yang biasa yang kita buat ialah usually the minimum adalah number of inputs, values darab dengan each of the variable. So kalau 3 kali 3 kali 3 kita ada 27 lah. Okay. And then after you already configure all the rules, biasanya to do this, kita gunakan the FAM, either cube ataupun table. Ikutlah berapa besar. Kalau banyak sangat variable tak boleh nak guna cube. Cube cuma boleh kalau 3 variable kan. Kalau ada 4 variable, you have to go through the tables. You kena pecahkan lagi. Okay, sebab susah nak tunjuk dalam bentuk 4D punya figure. Right, and then you have to choose the inference coding procedure. You nak guna teknik apa untuk inference system? Itu kita dah belajar dua, Mamdani style dengan Sugino style. So you pilih lah which one you are going to use. And then you have to choose a defuzzification strategy. Nak guna teknik apa untuk defuzzification? It depends on the inference juga. Kalau you guna Mamdani style, you can use COG kan, center of gravity. Tapi kalau you guna Sugino, you tak boleh nak guna COG sebab you tak ada graph. You ada spike or you have values kan, weights. So you guna weighted average technique. Ingat lagi ke tu?
Ingat.
Ya, dah tinggal 2 minggu rasanya benda tu kan. Last week kita tak ada kelas. Okay, so you tengok balik yang tu So defuzzification technique really highly depends on the inference technique. And then lepas you dah fuzzify, barulah you run. And then barulah kita nampak apa parameters yang boleh adjust. Okay, tune the adjustable parameters ni biasanya waktu you setkan dia punya fuzzy graph. Kita boleh adjustkan sikit fuzzy graph, dia akan lebih tepat. Macam fuzzy graph tu katakanlah mula-mula you buat, you design the graph, dia overlap sebanyak 50%. Graf itu lalu rapat-rapat berhimpit. So bila berhimpit tu mungkin ada lebih banyak rule akan fire, dia akan jadi lagi slow. Lagi slow dan mungkin juga dia punya ketepatan kurang. So you mungkin nak spread out a little bit punya graph. Ubah bentuk graph. So semua benda tu adalah parameters yang you ubah lah. Okay, so you can adjust that after you already run. And then you look at the output. Adakah lebih tepat ataupun tidak. Okay. Is it going to be better or not? Macam nak tahu tepat ke tidak, bagus ke tidak, you tengok baliklah tadi performance indexes yang you guna. Kalau you gunakan error kan, you tengok error lah. Error pun ada macam-macam measure kan. So you boleh gunakan yang tu untuk tengok ketepatan and the performance of the controller. Okay. So cuba you tengok dekat sini. Try to discuss how to design a fuzzy controller for these processes. Satu, hot shower system. Biasa guna hot shower system?
Tak biasa.
Tak guna.
Tak biasa guna Bangun pagi sejuk. Ini biasa dekat Malaysia memang jarang lah. Kat Malaysia hot shower system ni kita consider as a luxury lah. Kan?
Betul.
Tapi kalau masa saya dekat UK dulu, hot shower system is a necessity. Kalau tak ada memang freezing, mati. Tak mandi lah jawabnya. Sangat sejuk, memang sangat sejuk. Saya ingat lagi masa saya dekat sana, masa saya masuk rumah baru, saya baru pindah dengan anak kecil-kecil. You can imagine saya ada anak yang masa tu baby lagi, setahun. You can imagine baby kan, nak mandi so, cuaca dia sejuk. Dekat sana dia punya normal temperature, even pasal summer kalau you keluar panas lah, you dekat dalam rumah sejuk. So jadi bila dia sejuk, you nak mandi pun memang cinta lah. Kan? Kita ni orang Malaysia dah biasa, kita memang suka mandi dengan air sejuk tu. Tapi kat sana tak. So you need the hot shower system. So hot shower system tu dia kena ada controller sama macam aircon lah. Aircon kita set nak sejuk. Hot shower system kita set dia nak panas. Kalau air tak panas, you memang tak nak mandi punya. Sebab you akan menggigil-gigil masuk dalam air tu. Okay. So baik you tak payah masuk terus dalam bilik air tu. So you tak nak mandi. So bila tak mandi, it's not hygienic lah orang tak mandi. You tahulah, kita akan rasa macam tak selesa apa semua. However, yelah negara dia sejuk. Saya rasa saya duduk kat sana, saya tak pernah berpeluh. You pergilah berlari ke, buat exercise ke apa, you tak berpeluh sebabnya sejuk. So, it kind of macam, it's a change lah to us. Tapi itulah, katanya hot shower system is a necessity there. So, hot shower system ni proses dia, bila kita bangun, kita nak mandi tu, kita on, switch it on. We have to set the temperature of the shower tu. Air tu panas mana. Air panas sangat, you melecur. Air sejuk sangat, you menggigil. So you nak just the right nice temperature that you want to have a bath, have a shower. Okay. Cuma macam dekat UK dia sistem dia berbeza sikit dengan negara lain lah. UK ni dia tak tahu orang dia traditional sangat ke apa ke. Kalau dekat sinki dia akan ada 2 water tap. Satu hot water, satu cool water. So bila you nak basuh tangan pun it's kind of a problem to us. Bila you buka hot water tu memang air panas lah, macam air melegak. Buka air sejuk lah. So it's kind of macam you nak basuh tangan, tangan you kotor. You tak nak masuk tangan you dekat bawah air panas tu melecuh. You tak nak juga masuk tangan you dekat air sejuk tu sejuk. So you need it to be at the right temperature. So yang itu saya tak faham kenapa. Apa dia? Dia tak campur. Dia tak campur. Saya pun tak faham kenapa sistem manusia kat UK macam tu. Modern macam mana pun rumah dia orang, sinki dia macam tu. Shower taklah, sinki. So shower tu dia memang perlukan sistem. Kalau tak ada sistem tu memang dia orang akan freezing lah. Sebab dia dalam setiap rumah memang akan ada boiler. Boiler tu akan memanaskan air for the whole house. Sebab rumah tu dalam keadaan sejuk kan, dalam dinding dia ada pipe. So dia boiler on so that the whole pipe akan memanaskan rumah. So you are in the house, you don't feel very cold and so on. Sebab dia bila musim sejuk dia memang sangat sejuk lah. Dia below 0 degree. So kalau you tak ada heater memang you mati beku kat situ je. So macam tu lah. So they have that kind of need, really high need of having that kind of hot system. Tapi kita kat Malaysia kita lebih kepada nakkan sejuk, kita tak nak panas. Cuma adalah pagi-pagi buta bangun nak mandi nak pergi kerja cepat-cepat pukul 4 pagi katakanlah nak kerja train MRT katakan. So bila you kata you kena bangun pukul 4 pagi mandi sejuk kan. So you, tapi orang kita dah terbiasa dah, kita masak je lah air kan, campur dengan air panas, mandilah. Okay. So they want it to be easier for them to manage their daily life. So it is important there. So you can think of how do you think the hot shower system works. Okay. And then you can see the next is automatic fuzzy car wipers. Okay. What do you think about this? Wiper kereta tu.
Dia tengok jumlah air yang menitis.
Yes, yang automatic, dia tahu bila nak laju, bila nak slow. Kan? Kalau tak, yang kita pakai kereta biasa ni mana ada yang automatic kan? Tak tahulah, saya tak tahulah. Kereta saya tak ada. Kereta saya kereta biasa je. So bila kita pasang kadang tu hujan rintik-rintik tapi wiper tu macam nak terbang. Tapi kadang-kadang tu hujan dah lebat sangat dah ni. Kita pula tengah sibuk dengan anak dan kereta bising semua, tak sempat nak pegang, nak tolak wiper tu bagi laju. Jalan tak nampak, so dia jadi a lot of problems. So kadang-kadang kita nakkan wiper tu dia okey lah, dia tahu adjust sendiri. Hujan rintik dia slow down, hujan yang laju dia akan gerak lagi laju kan. So apa yang you kena fikirkan ialah what is the input of this and what is the output. Okay. And then rice cooker, saya rasa rice cooker kita pernah cerita sebelum ni kot.
Masa kot.
Ada kan? Masa kan? The how long it takes to cook the rice and so on. Okay. Vacuum cleaner. What do you think?
Rumba.
Apa dia?
Dia punya pressure yang tarik tu.
Suction dia tu kan?
Suction punya pressure.
Okay. Apa yang dia nak control mungkin the suction. Kalau atas kapet, you tak nak dia punya suction very hard sebab nanti dia tersangkut kan. Tapi dekat atas lantai, you nak dia suck all the dust on the floor. Ini biasanya for the yang kalau you tengok sekarang dah trend kan, orang beli vacuum cleaner yang robotik yang kan. Robot dia pergi jalan sendiri mengatur.
Jalan macam binatang.
Yes. Saya dulu pernah lah hari tu kena konon-konon kita try belilah, nak beli mahalnya yang Robby. So saya belilah yang murah-murah. Alah, ayam berancak ayam kan ada je. Tak kuat. Tak kuat pun. Berangan je lah. Tapi saya masa tu saya fikir macam it's okay lah, saya investigate so that I can study a little bit so that share dengan student ada bahan lah kan. So I bought one yang murah lah, tak adalah beli yang mahal. So tak apalah, dia pun jalan satu rumah. I don't think it actually cleans pun. Anak saya kata, Mami, it's just going round and round and round and round at the same place.
Jadi macam mainan.
Yes, it's going to at the same spot. Mungkin sebab dia tak ada intelligence to identify kat mana dia kena pergi. So dia kena carilah sampah tu sepatutnya kan. It should identify some sensor of identifying where is the dust actually. Should I move to the left or to the right? Ini tak ada, dia pusing dekat tempat yang sama.
Saya mahal tak silap saya, dia ada cara bila sensor dia langgar dinding tu dia pergi ke arah lain.
Yes. Tapi yang itu, yang murah tu pun dia langgar dinding, dia patah balik. Dia pergi dekat tangga, dia tak jatuh. Sensor yang itu intelligent, dia tak jatuh. Sampai kat tangga dia detect depan tu tangga, dia kena stop, so dia patah balik. Cumanya dia tak cari sampah tu. So dia akan pusing dekat setempat je lah, macam orang lari setempat kan. So kan tak ada fungsi sangat lah. It doesn't really clean. Anak saya kata, Mami, it doesn't go where I want it to go. Dia kata dia keluar daripada bilik. Itu jadi macam maid degil lah ni. So kemas bilik. So vacuum dalam bilik. No, dia keluar. Dia cari jalan keluar. So it doesn't really work. So mungkinlah yang intelligent tu dia intelligent enough to find a way to actually pick out all the dust. Sebab saya fikir dia tahu cari balik dia punya station. Ada yang robot yang mahal tu kan. Dia dah habis kerja, dia tahu mana station dia sebab dia nak balik dan charging. So you letak satu tempat, dia akan terus balik pulang ke pangkal jalan. Yes, so it know where to go. Okay. So bila dia tahu where to go tu dia intelligent enough lah to find a way. So pada saya mungkin dia ada sensor yang intelligent enough to find the dust, to do the work, or else it doesn't fulfill the job, kan? So itulah antara perkara-perkara yang mungkin you akan tengok bila you kata you are trying to look at the vacuum cleaner. Okay, air conditioning system kita cerita banyak daripada mula tadi. Water bath controller system. Water bath ni temperature juga untuk control takungan air. Biasanya digunakan dalam manufacturing juga. Sometimes people use it in large ponds yang mana yang orang belikan katakan. Ataupun dia orang bela buat ternakan. Tapi biasanya ternakan ni dekat laut dia orang buat. Cuma dia dekat sangkar-sangkar kan. However, if they built it inside, so they need to control a lot of things lah. One of it is temperature. Okay. Yang mana contoh you pernah tengok aquaria kan, they have some kind of a big aquarium inside buildings. Then they have living animals in there, so they have to control the temperature so that the animal will always feel like they are at home. Kan? Kalau you pergi dekat
habitat dia.
Dekat habitat asal dia. So you want them to feel like home. So macam kalau datang daripada Antarctic ke, dari Arctic ke, so dia nak temperature yang very cool and suitable for them. Sebab kalau tidak dia sakit kan, those animals dia perlukan environment tu. So itu antara contoh-contoh water bath temperature control system lah. Okay. Bukan water bath yang kita guna untuk mandi tu. Itu pun satulah luxury juga. Tapi biasanya kita punya shower system, water bath system dekat rumah kita tak payah controller. So kita can manage to control the water kan. Kita just tengoklah banyak mana air, panas mana kita nak kan. It doesn't really matter. But the importance of water bath temperature control system ni dalam sistem-sistem yang macam tu lah. Dalam aquarium yang besar. Contohnya, siapa pernah pergi Jepun? Kalau dekat Jepun memang banyak sangat aquarium indoor. Dia orang suka sangat bawa aquarium indoor.
Zurin.
Zurin pernah pergi Jepun
Pernah.
Kan? You perasan tak dia orang banyak aquarium dekat dalam?
Perasan banyak.
Kan? Sebab satu, Jepun ni dia punya negara memang keliling di laut, so dia banyak ikan. Cumanya dia suka bawa aquarium ke dalam sebab dia orang kan suka show off sikit benda-benda yang dia ada kan. So dia suka bawa lah benda tu ke dalam indoor. Saya perasan memang banyak indoor aquarium. Hotels ada, kalau you bergerak pergi mall pun ada, sebab dia tahu manusia ni suka pergi tempat-tempat macam tu. So dia nak introduce their marine life into the communities. So dibawa. So bila dalam keadaan macam tu, they have to really control the temperature of the aquarium. Sebab dalam laut dia temperature dia sejuk. Kita dekat dalam building ni panas. Jadi it needs to be adjusted and always be at the right temperature for the marine life. Okay. So saya nak your task today, okay, sebab dah dekat pukul 12 pun. Saya rasa kalau saya nak habiskan pun banyak lagi slide ni. Saya nak you all work in your groups. Just pick one of this, okay? And then you cuba identify apa input dia, apa yang you nak control dekat situ. Okay, apa you rasa variable-variable yang mungkin akan menjadi input kepada sistem you yang akan actually memberi kesan kepada dia punya output tu. Okay? Usually the output tu nampak macam temperature lah. Tapi jangan buat air conditioning system Allah, saya patut buang aircon ni. Aircon ni kita dah jadikan contoh banyak asyik cakap pasal dia. Nanti output dia sama je. You think of the others. Alright. Try to fikirkan dalam group you je lah. Ke saya nak kena buatkan group kat you? Ke you buatlah discussion sendiri? You want me to make a breakout room here?
Group sendiri je lah madam.
Group sendiri je lah
Group
kalau
sendiri
buat
je.
breakout room pun kan, you all rasa macam saya duk monitor pula discussion you all kan. Okay, so you all discuss in your groups and then identify satu, you discuss apa yang ada dalam tu. What other inputs yang akan terlibat di dalam you punya tu. Apa dia input dia satu dan apa dia punya values of the input. Okay, boleh
Boleh.
Okay, ada soalan? Setakat ni ada soalan?
Attendance madam.
Attendance? Lah. Oh tak apa, ni dalam Teams, saya ambil attendance dalam Teams.
Okay madam.
Okay, kalau dalam Teams saya tak ada masalah sebab Teams akan record attendance setiap kali you masuk, you keluar internet putus semua dia ada. Dia record semua.
Okay, madam.
Okay, asalkan you datang aja jadilah. Kadang tu you datang 1 saat pun saya tak perasan. So saya tak tengok time tu, saya tengok you ada dalam tu. Tapi berbalik pada diri you lah kan, you masuk kelas tu apa kan. Okay, alright, so that's it for today. Ada lain, ada soalan?
Doktor nak tanya doktor sikit pasal group project.
Group project boleh? Tanya terus dalam ni. Orang lain pun kadang-kadang ada soalan tapi dia tak nak tanya je.
Dia macam ni doktor. Kami punya group, domain dengan apa yang kami nak buat tu ada sama juga dengan kelas B. Ada dua plan buat yang sama, tak apa kah?
Tak apa. Tapi pada saya tajuk sama tak apa sebab cara you buat mesti berbezanya sebab otak orang lain-lain kan. Ali, you ni dekat depan komputer ke kat mana ke you duduk kipas je yang tengok komputer tu? Ali ke yang cakap tadi?
Bukan. Adik.
Adik?
Ya.
Awak muka Ali yang keluar kat sini. Bukan muka. Gambar bilik. Okay.
Tapi kalau nak tukar domain boleh ke doktor?
Boleh.
Okay, tak apa, saya try bincang dengan group saya.
Dan lagi, tapi tak apa, pada saya two groups doing the same thing tak ada masalah. Tapi report you takkan sama. If you do it yourself.
Okay, thank you.
Alright. Okay, yang lain ada apa-apa soalan?
Doktor.
Ya.
Saya ada 2 soalan. Yang pertama, saya ada rujuk kawan saya tapi dia macam student, boleh ke jadi expert?
Apa domain dia?
Domain dia Farid.
Kalau domain dia memang bidang dia, tak ada masalah. Dia student ke apa?
Dia veterinary.
Boleh?
Tu. Sebab kami buat pasal
kita
kucing.
Faham lah. Maknanya level expert tu level novice lah, bukanlah expert yang expert.
Betul. Jadi boleh masukkan dalam.
Boleh.
Okey. Lepas tu yang sistem demo dalam rubrik tu macam mana ya?
Sistem demo tu nanti masa present nantilah.
Dia nak kena present apa ya?
Present you punya project ya, you punya demo sistem you.
Tunjukkan, maksudnya guna MATLAB ke macam mana?
Tak kisah. Any system. Saya tak limitkan kena guna MATLAB tak. Any system, any coding, any. Tapi yang penting you boleh run system you dan saya nak tengok dia punya engine betul, okey lah.
Maksudnya boleh masuk output dan boleh keluar output macam tu?
Ya, betul.
Okay.
And it depends lah adik. Berbalik kepada, you cakap pasal output tadi tu, berbalik kepada user interface tu perlu atau tidak macam saya cakap tadi Kalau user adalah human, that we need to input give some input to the system, yes, we have to do that. Tapi kalau you buat some kind of a fuzzy logic control tadi, the input is coming from the machine or the sensor or something, so dia tak adalah user interface tu. Tapi you kena tunjuk jugalah macam mana input tu masuk.
Okay. Okay, thank you doktor.
Alright. Yang lain okey ke?
InsyaAllah okey
Madam.
Ya.
Okey doktor.
Siapa panggil saya tadi?
Saya.
Untuk grup keluar muka. Apa dia?
Untuk grup project tu, kat paper yang kita orang guna, dia ada pasal input temperature. Temperature guna value dekat India. Ada lagi 10.
Okay, again. Temperature India.
Sebab paper tu dia buat research dekat India.
Okay, temperature tu.
So dia ada sekejap So dia ada negatif 10 value dia.
Okay.
So dekat report kita orang tu kena guna value input dia ikut paper tu ke kena tukar ikut Malaysia punya temperature?
Ikutlah kalau you rasa nak tukar kepada Malaysia, tapi kalau you tukar kepada Malaysia mungkin akan berubah lah variable lain kan. Kalau you tak ada perubahan, boleh je nak guna data tu pun tak apa, saya tak kisah. Tapi you must be well versed lah, kena faham betul-betul kenapa you guna yang tu, apa effect dia kalau you tukar and so on. Okay.
Lepas tu tadi satu sekejap Saya nak tanya pasal rules. Kalau saya share boleh, madam?
Boleh. Saya kena stop sharing. Saya dah stop kan? Boleh?
Dah, madam.
Okay.
Sekejap madam. Saya nak tanya rules ni okey ke? Yang output ni kita orang buat sendiri. Madam.
Ya.
Saya nak tanya pasal rules ni. Yang dia punya output ni, if then lepas tu kita orang decide sendiri punya output.
Dalam paper tu tak ada?
Tak ada.
Kenapa saya nampak output dia sama je?
Oh tak.
Semua tan open je. Lagi kat bawah. How do you decide the output? Sebab you set sendiri tu kena tahulah macam mana you letak.
Kita orang ikut variable, macam ikut logic.
Ada expert ke yang verify?
Tak ada.
Patutnya kena ada expert verify lah. Kalau tak ada expert verify, mungkin you ikutkan some references from books ke apa ke, from any articles, and then kita terima.
Okay, saya rasa tu je. Terima kasih, madam.
Okay, alright. Lain? Yang lain okey ke? Okey. So kalau semua okey, tak ada apa-apa soalan lagi, kita sambung kelas kita next week.
Okay, madam. Thank you, madam.
Alright. Okay. Tak ada apa dah. Okay. Assalamualaikum.
Waalaikumsalam. Thank you, madam.
Waalaikumsalam. Thank you, madam.
Alright.
Madam.